Okay, so I'm going to join them up now. So using one colour, I'm going to join up A, B, C, D. A goes to B, A, B, C, D. So that's A, B, C, D got in front elevation. I'm going to get down a plan as well. A, B. Now we don't have C in plan, so we can only go A to B. We can join B to D as well, because A to D, because it's done front elevation. But that's all we can do. We don't know where C is. C is somewhere on this line out here, so we can't join up. So that's that much done. Then the next one then is A, B, F, E. So A, B is already there. F, E is already there because it's on the one line. So it's A, B, F, E is all on the one line. And down in plan then, A, B, F, E looks like this. Now, okay, and G I'm just going to leave floating there as a dot until later on in the question. So that's the setup as far as you could bring it. My next job now is to get point C, okay? Now, a load of people asked me about this over the last couple of days. So I just want to show you exactly how we get it, okay? We're going to create a parallelogram or a section of a parallelogram in front elevation, or we're going to use a horizontal cutting plane. But I wouldn't like to call it a horizontal cutting plane because it might not be horizontal. So we'll forget about the word horizontal cutting plane and instead we'll call it a parallelogram rule. We have a completed front elevation. I have AD in front elevation, I have AD in plan. I have AB in front elevation, I have AB in plan. I'm missing BC or CD, okay? So what I'm going to do is I'm going to take the angle of AD in front elevation. I'm going to bring it to what I'm looking for, which is C, and I'm going to draw a line across. And that finds a particular point, call it X, in front elevation. And X is on the line AB. So I can bring X into plan. Okay. There it is there. Down in plan. And then I just have to remember what I did. I took the angle AD through C in front elevation. So I should take the angle AD through C down in plan. That line that I've drawn there is on the surface ABCD. It's on the surface ABCD here. So that means this has to be C. So I have found C now down in plan, which means I can complete my plan of my object. Okay? That's very, very important, that step. The next stage of the video now, I'm going to find a dihedral angle. Okay? So, to find a dihedral angle, there are a couple of steps. Step one, you need to find the line of intersection. In this case, we have the line of intersection because AB is common to both. AB is the line of intersection. We have to find the true length of the line of intersection, but what we're actually finding is what angle is that line traveling at? What's its true inclination to whatever plane we start in? I then need to bring 1 point from one surface and 1 point from the other surface. I look along that true inclination and I'll find this V shape that we're looking for. So, step one. We're going to find the inclination or the true length of the line AB. So I'm down in plan. Doesn't matter where I start, but I always start in plan. And I'm going to go 90 degrees to AB. And wherever I want, just outside my plan, I'm going to draw another XY line. Now, I need to bring out 1 point from one surface and 1 point from the other surface. So I'm going to bring out point F. I'm going to bring out point C. Okay? So I brought 1 point from one surface and 1 point from the other surface. Now I need to get these points out here. So I'm going to use my compass because this is elevation, plan, plan, elevation. So that means A, the same height as up here. So A has a 0 height, so that will be A. This is the height of B, so I'm getting B here. It's also the height of F. So I'm able to find B right there. And I can find F also. And I can get the height of C as well. Now, just want to pause the video for a second here just to explain something. I have a video done back in my videos about finding the dihedral angle first and using the dihedral angle to find this point C in this case that we're missing. It's well worth the watch. Okay, it's based on the 2011 dihedral angle question. I'd have a look at that and see. It just helps explain a lot more information about that parallelogram rule. It's just a longer method, but it just reinforces what I've done there with that blue line. Anyway, so I have the true inclination now of AB got, so I can join A to B. So that's the true length of line of intersection. Okay? Now, next step. I need to look along that true length. So I'm going to look along the true length line of intersection. The same angle. I'm going to bring C and F at the exact same angle using sliding set squares. C, F. And wherever I want, just outside, I'm going to construct an XY line. Now, so we have plan, XY, elevation, elevation, XY. This is a plan. That means from this elevation into plan will be this elevation into plan. So, what you'll find is that A and B will now become a full stop, which is a good thing, because when you look along a line, it should become a dot. So, A and B, so I'm working from this XY back to get A. It's the same as for B. So that now is where A and B are. This XY to F, it's only a tiny little distance from me, is this XY to F. And then finally this XY to C will be this XY to C. Join them up, and I'm going to get my dihedral angle. So that's one side of it, and this is the other side. Now you should get your protractor out, and you should measure that angle. Now I'm going to pause the video again now. Okay, so that's part A and part B done. Okay, of this question. I'm going to start into C and D now, in relation to an isosceles triangle and finding the line of intersection. Okay, so I'm going to pause the video at this point. Make sure you can get this far. This is what's important. This is what comes up quite often. This is very, very important to understand. Next two parts, they may appear again and they may never appear again. It requires you to think on the spot really. But the first two parts, extremely important.